In this video, we're going to look at how to factor special cases. So we're still going to be factoring, but our quadratics are just going to look a little bit different. So we have two kinds of special cases. One is when your b value is equal to 0. So you might be given something like 16x squared minus 25. If you have a binomial, that's going to be your first sign that it's a special case. And then the difference between these two examples that we're going to look at is that for one of them, the b value is 0, and for one of them, the c value is 0. So if b is equal to 0, this is called a difference of two squares, meaning that the two numbers are being subtracted from one another, and they are both perfect squares. A perfect square being 16 because it's 4 times 4, or 25 is a perfect square because it's 5 times 5. 4 is a perfect square because it's 2 times 2. So it's important that you know what your perfect squares are so that you can recognize that you have a difference of two squares. You still need to make sure that if it is this case number 1, you are still looking for a greatest common factor, okay? And your hint can still be that if you get to the end of the problem and one of your factors has something in common, so for example, if that had been 4x minus 8, and those are both divisible by 4, then you know that you missed a GCF at the beginning of the problem. So to factor a difference of two squares, again, both of the terms should be perfect squares, meaning that I can take the square root. So if I take the square root of 16x squared, the square root of 16 is 4, and the square root of x squared is just x, because x times x is x squared. Then the square root of 25 would be 5. So my answer is going to be 4x plus 5 and 4x minus 5. The order doesn't matter, so you could write 4x minus 5 first and then 4x plus 5 second. That would be totally fine. But this is the rule for the difference of two squares. So one needs to be addition and one needs to be subtraction. And the original problem, the constant has to be negative. So it's got to be that it's 16x squared minus 25 and not plus 25, or it wouldn't be considered a difference of two squares. And again, I'll reiterate this when we get into the examples, but for this one, you can always check your work. So 4 times 4 is 16x squared. Then 4 times 5 would be a negative 20 and then a positive 20. Well, a negative 20x and a positive 20x are going to cancel out, which is what we want to happen because our original does not have a b. And then 5 times negative 5 is negative 25. So we end up with 16x squared minus 25. Okay, for our special case 2, this is when you don't have a constant. Okay, so the constant is 0. In a situation where the constant is 0, it is just a problem with a GCF. So for this example, 8x squared minus 12x, we can just factor out a GCF. So 8 and 12 are both divisible by 4. But even more importantly, 8x squared and 12x also both have an x. So I can factor an x out. Normally, I can't do that because there's a constant that doesn't have the x with it. But in this case, if you don't have a constant, you can factor out the x. And so your GCF goes in front of the parentheses. And then when I divide, 8x squared divided by 4x gives me 2x. And then negative 12x divided by 4x just gives me negative 3. The x's cancel out. So that's where the 2x minus 3 in the parentheses comes from. And again, you can check. So we can distribute the 4x inside the parentheses. That would give me 8x squared. 4x times 3 would be 12x. And so that would be the correct answer. So example 1, 30x squared minus 12x. We know that this is a special case because it is a binomial. Then we need to ask ourselves, are we missing the value for b or are we missing the value for c? Which one is equal to 0? On this one, the c is equal to 0. If c is equal to 0, that means that we are looking at a problem that only has a GCF. So I would need to figure out what can I divide 30 and 12 both by. And then remember that the GCF is also going to include an x. So I can divide 30 and 12 both by 6. And I can divide x squared and x both by x. So your GCF goes in front. And then when I divide 30x squared divided by 6x, I get 5x. I don't have x squared anymore because I'm taking x squared and I'm dividing an x out of that. And then again, if I check this and I multiply, 6x times 5x will give me 30x squared. Then 12 divided by 6 is 2. And this is factored. Example 2, 48x squared minus 27. So in this example, I'm missing my value for b, which tells me that this will most likely be a difference of 2 squares. 27 is not a perfect square and 48 is not a perfect square. So that's a little bit of a hint that I am going to have a greatest common factor in this problem. So I can divide both of these terms by 3. I cannot divide by 3x, so we need to make sure we don't confuse the two scenarios. The only time you can divide by 3x would be if both of these terms had an x and I didn't have a constant. Okay, so 48 divided by 3 is 16. So the GCF goes in front. This would be 16x squared. 27 divided by 3 is 9. And now this is a perfect square and 9 is a perfect square. So I can take the square root of both of those terms and that will give me what's going to go into the parentheses. So 16x squared would be, the square root of that would be 4x, and the square root of 9 is 3. So my final answer is going to be 3 in front, and then 4x plus 3, 4x minus 3. And that's my factored form. Example 3, 2x squared minus 32. Similar to the last one, I don't have a b, but I do have a constant. So this is most likely going to be a difference of 2 squares. I do have a GCF of 2. So I would factor out a 2, and I'm left with x squared minus 16. X squared is a perfect square, and 16 is a perfect square. So this is a difference of 2 squares. The square root of x squared is just x, because x times x is x squared, and the square root of 16 is 4. So my final answer would be x plus 4 and x minus 4 with a GCF of 2 in front. Example 4, 10x squared minus 35x. On this example, I do not have a value for c. I don't have a constant. So this is just going to be a straight GCF problem. We want to find the GCF of our coefficients, and then we want to also take an x out, factor an x out of the expression. So I can divide 10 and 35 both by 5. And then I can also factor out an x. So 5x will go in front of the parentheses. 10 divided by 5 is 2. X squared divided by x is just x. 35 divided by 5 is 7. And then the x's will cancel out, and this is my factored form. Example 5, 16x squared minus 36. So this one we need to be really careful of because 16 is a perfect square and 36 is a perfect square. So what you might be tempted to do is say, okay, well, the square root of 16x squared is 4x, and the square root of 36 is 6. The problem with that is that would give me 4x plus 6 and then 4x minus 6. Now, what's wrong with that? If I FOILed that, I would get 16x squared minus 36, so it seems correct. However, you cannot have a greatest common factor within the terms in your factor. So the 4 and the 6, because those are both divisible by 2, that's a red flag that I missed a GCF at the beginning of the problem. Here also, 4 and 6, those are both divisible by 2. So this would not be correct, okay? So we can come back to the beginning. 36 and 16 are both divisible by 4. So I can factor a 4 out of the expression, and I would be left with 4x squared minus 9. Which is still a difference of 2 squares because the square root of 4x squared is 2x. 2x times 2x would give me 4x squared, and the square root of 9 is 3. So this would be 4, 2x plus 3 times 2x minus 3. And this would be the correct factored form. Example 6, 15x squared plus 7x. This one is just a problem with a GCF. Now this one might stump some people as well because I can't divide 15 and 7 by anything other than 1. So my greatest common factor when I'm looking at the coefficients is just 1. But that's fine. You also have the variable in common. So you would only be factoring an x out of this expression. So I would have an x in front of the parentheses. 15 divided by 1 is still just 15, and then x squared divided by x is x. And then plus 7x divided by x, the x's would cancel, and this would just be plus 7. And this is my factored form. For example 7, this is a difference of 2 squares. 4 is a perfect square, and 25 is also a perfect square. I do not have a greatest common factor because I can't divide 25 by 4 or by 2. So the square root of 4x squared is 2x, and the square root of 25 is 5. So this would give me 2x plus 5 and 2x minus 5 as my two factors, and this is my factored form. For our last example, 3x squared plus 3x, this is a GCF problem. So 3 and 3 are both divisible by 3. So I can factor a 3 out of both of these, and then they both have an x. So I can also factor out an x. So 3x would go in front of my parentheses. 3x squared divided by 3x, 3 divided by 3 is 1. Now we need to remember we don't write a 1 in front of the x. X squared divided by x would leave me with just x. Then 3x plus 3x, students tend to say, okay, well those cancel out. That would mean that this was just your answer. Well, if you went to check it and you went to multiply, you would only end up with 3x squared and you wouldn't end up with the plus 3x. So we need to be careful. If you are dividing anything by itself, it is 1. So 3x divided by 3x is 1. And then if I were to FOIL, or not FOIL, but just multiply, I would get 3x squared, and then 3x times 1 is a positive 3x. So then I know that I did it right. So my final answer would be 3x times x plus 1. And this would be my factored form.